Am I audible to everybody? So we don't have much time. We have a couple of questions to solve today, and I would love us to move quite quickly. So please, the class starts right immediately. You can see the question we have right in front of us. So we're starting with a binary operation question. We'll be solving other questions also. We'll be solving questions on trigonometry, and we'll be solving question on matrix, and possibly, maybe, although very unlikely, we solve question on mathematical induction. But if we can't solve today on mathematical induction, we'll be solving tomorrow unfailingly. We have to solve probably more than one question on mathematical induction. Now, literally every question I'll be solving today are all questions A-level standard, Jupeb standard. So I would love you to take notes on every one of them so that we can have our desired result. All right, so this very first question, binary operation. We're told that a binary operation is defined on the set of real numbers. And we're given the condition on which the binary operation is defined on. We can see right here that it's defined on this particular function. Now, when you see something like this, this is the set of rules that your binary operation will follow. So anything you are given has to follow this format. Now, you're told that you're supposed to solve for x in this particular function. Look at what the function we have right here. We're supposed to solve for x. Don't forget, you can see x right here. And don't forget again, this is the binary operation we're using. This is what our binary operation is defined on. Obviously, this tells you already that when you're trying to solve this particular question, you have to, for x binary operation 3, so we have x binary operation 3, we have to revert back to this particular function because this is the rule that the binary operation follows. So when we are dealing with x binary operation 3, in this case, we will be having, of course, p here is x and q here is 3. So we'll be having x as p plus q as 3, then plus p times q, that will be 3 times x, that will be 3x. So that's our value for this particular aspect, x binary operation 3. Let's try and solve for 2 binary operation 3, which is the second aspect. So 2 binary operation 3, of course, again, you have to make use of what you were given, the rule you were given. So in this case, we are having our p as 2, our q as 3. So we have 2 plus 3 plus pq. That will be 2 times 3. Of course, your p here is 2 and your q is 3. That will be 6. So looking at the question, we are told that x binary operation 3 plus 2 binary operation 3 is equals to 18. That's very key to everything we're doing. So what do we have to do next? We bring these two together because this represents this now. So we have x plus 3 plus 3x. Now this plus is what joins the both of them together. Then 2 binary operation 3, we have 2 plus 3 plus 6. And we said everything was equals to 18. So I'm sure you can see what's going on here. We have x plus 3x. X plus 3x obviously will be 4x. That will be 4x plus 3 plus, now we have 2 plus 3 plus 6. That gives us a value of 11 equals to 18. So what we have here is 4x plus 3 plus 11 will be obviously 14. That will be 14 equals to 18. What you can see here is that you can obviously see your result for your x coming out already. That means we have 4x will be equals to 18 minus 14. 4x obviously will be equals to 4. Our x here will be equals to what? 1. So if you can see what we're doing right here, you can see that solving using binary operation is quite very easy. All you just need to remember is that you have to follow the rule of law that was given to you. So we're told that the binary operation is defined on this. That is very key. When you are given a question on binary operation, the very first thing you want to look for is what is it defined on? Is it defined on this? Is defined on this? That will be what will be your yardstick of solving anything in that particular question. So I really hope this was clear for everyone to understand. Let's quickly go to the next question. We'll be solving quite a number of questions today. I hope this was clear to everyone. Do anybody have any confusion in this? Well, I don't think so. All right, let's move to the next question. Let's try something in matrix. Let's try a particular question in matrix. Now, all these are Jupeb past questions, so you have to note them very much. So under matrix, we were told that we have the identity matrix defined. Okay, let me. All right, so look at this question right here. We're told to find the square of an identity matrix. This was the identity matrix given, IN. So we're told to solve this. The square of an identity matrix is what? Now, I don't know if you have an idea of what to do here, but can you see what's going on here? First of all, we're not told the dimension of this identity matrix. We're not told if it's of order 1, or sorry, of order 2, or of order 3, or of order 4. Now, let me quickly tell you something about what you have here. If you are given high 2, this obviously is telling you that the identity matrix is of order 2. So we're talking about something like this. If you're given high 3, so you need to be careful of understanding what n actually signifies here. This is an identity matrix of order 3. That's just the way to represent it. And then you can go on and on and on. So then you were told to find the square of an identity matrix. We're told to find the square. That means they're telling you to find, and in this case, they didn't even give you the dimension. Maybe it's order 2 or order 3. So they're saying of an order n. That means you're supposed to find I2, for instance, square. So what's going to be your value? Now, when you are faced with a question like this, you need to just remember one thing. Of course, we're going to try and prove it here so that it will be much clearer to you. When you square any identity matrix, either of order 2 or of order 3 or of order 4 or of order 5 or whatever the order is, you will always get the identity matrix back. So the square of an identity matrix of order 2 is always going to be the identity matrix of order 2. If you go on to square an identity matrix of order 3, you would go back to still get the same identity matrix of order 3. So this means every identity matrix, when you square it, will always bring you back to the same identity matrix. Let's just prove that with an identity matrix of order 2 so that it will be much clearer and you don't have to spend time on questions like this. So how do you find the square of an identity matrix of order 2? Of course, you were told to find of order n. That means any order. So you can go back to, if you're told to prove to, if you're asked to If you are asked to find the identity matrix of any order, the square of it, all you need to do is to tell them that whatever the order is, it will still give you the same identity matrix. So this is going to be our final result, that the square of an identity matrix of order n is equals to the identity matrix. This is our result. This is the answer to that question. This is the answer to the question. But let's prove it so that we don't just assume that. If you have an identity matrix of order 2, so obviously you have something like this. Of course, when you are doing the square of this, you are going on to do this times this. I'm sure we all know that. And looking at what we have here, if you're deciding to multiply these two matrices together, to do the multiplication, this would be row 1 times, I'm sure you remember the whole thing. So what we'll be having is 1 times 1, that'll be 1, plus 0 times 0, that'll be 0. For the next one, we have 1 times 0, 0, plus 0 times 0, 0. In this case, for this one here, we have 0 times 1, 0, plus 1 times 0, 0. For the next one, we have 0 times 0, 0, plus 1 times 1, 1. You go on to solve this, you will get a value of, this will be 1 plus 1, this will be 1, 0 plus 0, this is 0, 0 plus 0, this is 0, 0 plus 1, this 1. You can see that trying to square an identity matrix of order 2 still gave us the identity matrix back. So obviously, this theorem is actually proving that the square of an identity matrix of any order will always give us the identity matrix. All right, let's go to the next question. Let's solve a question on trigonometry. All these are Jupeb questions, so you need to be very mindful of them. Now look at this question and pay careful attention to it. You were told that if this was for last year, this came out last year, this was one of the questions that came out 2025 Jupeb. And this is a theory question, by the way. And it carried 5 marks. So this question carried a total of 5 marks. You were told that cos 60 was this. You're now then told to find tan 15 degree. So I'm sure you can see exactly what we're dealing with here. We are told that cos 60 degree was equals to 2 tan 15 degree over 1 plus tan square 15. You are then asked to find tan 15 degree. Do you want to make an attempt to it under 2 minutes? Do you have an idea of what to do? Imagine you're in an exam hall. What's going to be your first approach? What's going to be your first approach to this particular question? Quite very simple, but you have to be very much sound with trigonometry. It doesn't take it. You're not going to use so much time to solve this question. It's quite simple. Is there anybody there with an attempt on this? Can you just signify? Just say yes, I know what to do. Just let me know. Okay, this person said he doesn't have an idea. Okay, anybody with an idea? Using basic functions, okay. Basic functions, okay. And any other person there? Okay, tan 45 minus 30. Okay. Tan 45 minus 30, doing 15. All right. Any other approach to that? Okay, so let me just give you the hang of this. It's not very complex at all. You have to just take things very simply. So the very first thing I want you to identify here is somebody is talking about compound angles. Just so you know, in the last test I gave to class 2, I was quite shocked at you people's approaches to simple questions. You have to learn to always look at questions with a more you don't have to always see questions in the light of being very complex and difficult. This question is actually not as complex as that. The very first thing you have to identify here is you can see cos 60 degree. So what's cos 60 degree? That's the very first thing. And if you remember when I was explaining something around what we call special angles. And I told you that the special angles are obviously we have 30 degree, we have 60, we have 45 degree, and we have 60 degree. We call these special angles in the sense that you don't necessarily have to punch your calculator to get these values. You can get these values without having to punch your calculator. So how do we get cos 60 degree? Using our special triangle, we have this being 60 degree, we have this being 30 degree, this being 30 degree, and this is 1, 1, 2, 2, and this is sort 3. So you have to be able to always draw this triangle easily. So from what we have here, what's going to be cos 60 degree? Cos 60 degree will obviously be equals to, that's adjacent over hypotenuse. If this is 60 degree, obviously this is your opposite. This is your hypotenuse, this is your adjacent. So obviously cos 60 degree is the same thing as 1 over 2. So I can replace cos 60 degree with 1 over 2. All right, I'm sure nobody finds that difficult to understand. So wherever I see cos 60 degree now, I'm going to be replacing it as 1 over 2. So I can say I have 1 over 2 equals to 2 tan 15 degree over 1 plus tan square 15. All right. Now, looking at what we have here, what's the next step to take? All right. Let's do something quickly. What if don't forget we are told to find tan 15 degree. What if I decided to take tan 15 degree to be x? What if I decided to, so that if I'm able to solve, look at it this way, if I'm able to find x, I'll be finding tan 15 degree easily, because tan 15 degree is what I'm interested in. And instead of course, you can easily decide to continue solving like this, but it may be a little bit complex, especially for those that may not be able to follow through with tan 15 degree being present. So what we would like to do is to just take our tan 15 degree to be x. So we'll take x to be tan 15. So at any point in this solution, once I'm able to get my x, I've gotten my tan 15 degree, which is what I'm interested in. So I don't have to go on compounding the angle 45 minus 30, because I know that tan 15 degree is what I'm interested in. So let me go on to try and find tan 15 degree by substituting tan 15 as x. So obviously I'll be having 1 over 2 will be equals to 2. Tan 15 degree is x now, so I'll be having over x. Don't forget this is last year question, so you could have seen this in your exam if you did the exam last year. This was one of the questions they brought out in the theory question. So this is 1 plus, this will be tan 15. This, don't forget, tan square 15 is the same thing as tan 15 everything all square, which I can easily write as x squared. All right, this looks nice now. This looks nice and more comfortable with solving. So I'm sure you know what I need to do next. I need to cross multiply. I'm deciding to cross multiply this. I'll be having 4x will be equals to 1 plus x squared. I'm sure we all agree with that answer. And I can rewrite this easily as x squared minus 4x plus 1 equals to 0. Now, looking at this is x squared minus 4x plus 1. Now, the next thing is, how do I solve this? Obviously, I just need to use whatever method I'm able to use to find my final answer here. So I need to go on to find for x. So how do I find for x? Do I use factorization? Let's see, can we use factorization here? We have 1 times 1. No, I don't think factorization will actually work here. So what we can decide to use is to use your formula method. So I want you to do something. And can you please go on to solve this using the formula method? And I'll be solving mine while you can solve yours also. Don't forget the formula. In case you have forgotten the formula, let me write it here for you. The formula when you're dealing with using the formula method is what? Minus b plus or minus square root of b squared minus 4ac everything over 2a. And I'm sure you know that for this question now, your a will be 1, the coefficient of x squared. So your a is 1, your b is minus 4, and your c equals to 1. So obviously you have a as 1, b as minus 4, and c as 1. So replacing all this into this particular question, let's see what are you going to get. Can you go on to solve, and let's get our final answer. So don't forget, once we're able to get our value for x, that will be times 15, which is what we're interested in. So all we need to find here is x. So fixing this up, our b is minus 4, so we'll be having our x to be equals to minus 4 plus or minus square root of what's b squared, that's minus 4 squared, minus 4 times what's a, our a is 1, our c is 1, everything over 2 times a, which is 1 also. So going on to solve this, we have this will be 4 minus times minus plus or minus square root of, this will be 16 minus 4, everything over 2. I'm sure you can follow this. So this will be equals to 4 plus or minus square root of 12 over 2. So I'm sure with your understanding of sorts, I'm sure you agree with me that I can write my sort 12 to be the same thing as 2 sort 3. Obviously, that will be square root of 4 times 3. And this will be square root of 2 square times 3. This will be square root of 2 square times 3, which will be 2 sort 3. So my square root of 12 is the same thing as 2 sort 3. So I can go on to write this as 4 plus or minus 2 sort 3 over 2. All right, I'm sure you guys are following. Okay, somebody said x is equals to 2 plus square root of 3. Okay, let's go on. You would understand our final answer. Please pay full attention. There is something I need to talk to you about when you are getting your final answer here. So our x is 4 plus or minus. So let's say, let me write it in a much more clearer place. So we can see x equals to 4 plus 2 sort 3 over 2, or x equals to 4 minus 2 sort 3, everything over 2. In this place now, I'm sure you know you can factorize 2 out. So you can have 2 into bracket 2 plus sort 3 over 2, or you can do the same thing here, factorize 2 out, 2 into bracket 2 minus sort 3 over 2. 2 cancels 2 here, 2 cancels 2 here. So I can end up saying my x is equals to 2 plus sort 3 or 2 minus sort 3. How many of you got that? These two answers, please. Now, this is what I want to tell you. What is SOT 3? What's square root of 3? Plus 2. Okay, somebody said he did this to decimal. So when you did yours to decimal, I think 2 plus SOT 3 is supposed to give you and 2 minus SOT 3 should give you all right. So for some reasons, which I would, this particular answer is often seen as an extreme answer. So our tan, of course, our tan 15 was this and this. So we'll be mostly leaning on this as our final answer. That's 2 minus SOT 3. I don't know if you can see the board well. The 2 minus SOT 3 is what will be. Of course, both answers were gotten, but our final answer will be more of 2 minus SOT 3. I could explain that very later, but for this particular question, this is how we solve it. So this is, again, as I said, this is a question that came out last year, and I'm sure you could have been in the hall also. So this is a very likely question, or something in this form, very much likely to come out. I want to solve another question, also a past question that I feel you should pay very much attention to. So we're told that if the cos of x plus alpha is equals to the sine of x plus beta, we're then told to find the tan of x, and we're told to leave our answer in terms of alpha and beta. So we're told to find the value for tan x, and we're also told to leave our value in terms of alpha and beta. So this is also a past question, as I said already. So these are some of the likely questions or something of this form that you should be expecting. And by those of you saying you don't use SOT, I would advise you, when you are in a theory question, you should always try to lean more towards SOTic answers, especially when you see there are possibilities in solving, because it makes your work much more neater, and you tend to see much more better possibilities. All right, now we have this very interesting question in front of us. We're told that the cos of this is equal to the sine of this. Who can tell us exactly under what topic do we have this? This looks like something you have seen before. Well, this is what we call the compound angles. This is the compound angle, and I'm sure by now you are very much familiar with this compound angle. In case, for those of you that could have forgotten it, let me remind you of what our compound angles were. So the cos of A plus B, according to our compound angle identity, told us that the cos of A plus B is equals to the cos of A plus B is equals to the cos of A, the cos of B, minus the sine of A, the sine of B. Of course, that's what we'll be needing that so much for this particular question, and that's why you have to make sure you know all these things. Also, because we can see the sign of a compound angle is also featured here. So the sign of A plus B is also equals to, according to our compound angle identity, is equals to the sine of A multiplied by the cos of B plus the cos of A multiplied by the sine of B. So obviously, these are all compound angles identities that we should all be aware of. And we have to now go on to replicate this. So instead of having the cos of A plus B now, we're having the cos of x plus alpha. So that means we'll be having the cos of x plus alpha to be equals to, now using the compound angle, we'll be having the cos of x, the cos of alpha, minus the sine of x, the sine of alpha. So you can see what you have right here. You can see that this is the very first step we're going to be using. And then for the other side, the sine of x plus beta will be equals to the sine of x, of course, using this particular identity, the sine of x, now the cos of beta, then plus the cos of x, then the sine of beta. So we are told that these two things are equal. We are then told to find the tan x. We are asked to find tan x. How do we find tan x? Now, let's decide to, because we know that our tan x obviously will be sine x over cos x. We'll be looking for a way to arrive at a value that will give us sine x over cos x. Now, if you look at let's try and get these two things together. So let me just write it right here. So let's just write this in full. So we have cos x cos alpha minus sine x sine alpha is equals to sine x cos beta plus cos x sine beta. So what we can do now is to try and group where we can see our sine x and where we can see our cos x. So let's try and fix in all of the sine x to this side and all of the cos x, probably all of the cos x to this side, and anyhow you want to do it, but I would love to move all the cos x here and then the sine x here. So looking at this now, I have, don't forget I told you already, you have to always look at your final answers before we are told to find tan x. And tan x is obviously, I'm sure you remember that from your identity, tan x should be sine x over cos x. So when I say I want to move sine to one side and cos to one side, you should understand that the rationale for that is because I want to find a way to see if I can bring out sine x over cos x. So I want to move all the cos x to one side and all the sine x to one side. So peradventure, I can find a way to then make sine x divided by cos x. Then that will give me my answer. So if I move all the cos x to this side, of course, I have cos x here, cos x, cos alpha. Then I have cos x sine alpha. When it comes to this other side, we return to minus cos x sine beta. Then I'll be having equals to, now we have all the sine x in this other side. Then I'll move this one here, this will be plus sine x sine alpha. So the next thing to do now is to find a way to factorize both my cos x and my sine x. So let me go on to factorize this. Obviously, this will be cos x into bracket. I'll be left with cos alpha here. Then I'll be left with sine beta here. While for this other side, I'll be left with, factorizing sine x, I'll be left with cos beta plus sine alpha. So this looks more like what we're looking for. You can see that we have been able to come to a place where our values are looking more likely to be seen. So this is a nice place to be, because obviously I can see that if I decide to divide through by, for instance, I can decide to isolate cos x. So I can decide to go on to say divide both sides by cos x. I'm sure you can follow what's going on here. So if I divide both sides by cos x, I'm seeing already that, look at what's going on here. Of course, this will cancel this. So this will cancel this. I'll be left with cos alpha minus sine beta. In this other place, if I do sine x over cos x, I'm sure you can see that this is going to bring my tan x out. And then if I can get my tan x, then I can isolate tan x by dividing both sides by the other coefficient. So this is how you tackle questions like this. You find a way to move towards where you are interested in by using all you know about trigonometry. So looking at this now, I've been able to get, let me write this on the left-hand side now, just sine x. Okay, you know what? I think I'm okay in writing, if I write sine x over cos x, I can go on to then fill this in somewhere here. Cos beta plus sine alpha then is equals to what we have here. This is cos alpha minus sine beta. You can see how interesting this is. So obviously, it's not wrong if I go on to write my sine x over cos x now as tan x. I can write this as tan x now. Tan x, then cos beta plus sine alpha equals to cos alpha minus sine beta. I'm sure you guys are flowing with what's going on here. Quite very interesting, right? So I was going to find tan x. So if I go on to divide both sides now by whatever was disturbing tan x from coming out, which is cos beta plus sine alpha. So I can decide to divide this by cos beta plus sine alpha, dividing through both sides. Cos beta plus sine alpha. Okay, now looking at this, I'm sure you guys can see that my tan x is isolated already here. It will be equals to cos alpha minus sine beta over cos beta plus sine alpha. Don't forget, this was the question they initially told us to get through. We were told to find tan x in terms of alpha and beta, and we have successfully been able to get this answer. So this is perfect, perfectly done. So this is how you solve, you tackle questions on trigonometry. You have to be confident. You have to ensure you move accordingly, ensuring that everything you know about it, you put it into use while trying to solve. So do anybody have any question on anything we have done so far? Or are we moving together? Are you flowing with what we're doing? Is it perfect? Oh, somebody said he doesn't understand. What part of it don't you understand? Okay. Okay, this is who is Messi? I don't know. Okay. So I think the major thing you have to do is to probably when the live video is released, you will have to start from scratch because to understand questions like this, you have to always start from the beginning and flow from the beginning. So we don't. It's not always easy to get into a particular question and understand it. So I want us to take a matrix question before the end of this class, and it's also going to be from just verbatim what came out last year, so that once we are done with all these things, I'm very sure you can have A in everything you're doing. So we are picking up a theory question which carried a total of 7 marks on matrix. That's question number 2 of mass 001. So I'm going to bring out the question verbatim so you can in case you want to see it, I don't know, is it possible for you? Okay, I think it's actually possible to see it this way. So that's the question we'll be solving. You can see it there in case I'll be writing it, don't worry. But this is verbatim. You can see the marks there. We have 7 marks awarded to this question on matrix. So you have to be perfect in everything you're doing so you can get every mark you are. All these things are very likely questions. And once you are able to solve them, that is the way you are going to accumulate your marks and have your A. All right, so let's move very quickly. The question read that let A be the matrix of coefficient of the variable of the system of linear equation. I remember telling them, most likely I remember doing that it is very likely for Jupeb to bring out questions on system of linear equation because it's one of the most examinable parts of matrix. So I would not like us to ignore that. I would love us to be very much perfect, that everyone can solve every question on system of linear equation. It came out not just in the theory, but it came out also in the objective. I can show that to you very much later. It's present, the same system of linear equation present both in objectives and the theory question. So they were given this particular linear equation, and what they were told to do was, the first question read, generate the adjoint of matrix A. Generate the adjoint of matrix A. And that was 3 marks. And then question number 2 read, what is the inverse of matrix A using the adjoint? And then question number 3 said, use the inverse of matrix A to find the solution of the system of the given linear equation. So these are the questions that were asked of them last year. So can you start trying this out? And first, can you try and find the adjoint? I'll be finding it on my own. Can you be doing it also so that we can flow together? For those of you that know it, you can keep solving. So for us to, the very first step here is for us to bring out our matrix. Don't forget, our matrix is the coefficient of these linear equations. And they told us that that was matrix A. So for here, we have coefficient of x1 as 1, 2, and 3. That gives us the first column. And for the other side, we have the coefficient as -1, 1, and 2. That gives us the second column. And then for the other side, we have 1, -2, and 1. That gives us the third column. Now, don't forget, we're going to have a matrix identifying the variables. So that is the second thing you need to do. And the last matrix you'll be having will be the matrix identifying the constant. That'll be 4, 1, 5. So this is the very first thing you have to do. The very first step you have to do for you to be able, I believe nobody in this class should miss any mark out of these 07 marks in case this came out. Because this is for last year, and this is 7 marks out of a possible 15 that was all apportioned for this question. So let's see how to find the adjoint first. How do we find the adjoint of matrix A? You were told to find the adjoint of matrix A, and you were told that the matrix A was this matrix, the coefficient of the variables. So how do you find the adjoint of this particular matrix? How do we find, somebody is talking about binary operation. When the video is released, hopefully tomorrow you will have the opportunity of going back to those things we solved. But right now we are under matrix. So and in case you don't still understand, then we can find a way to still get back to that. All right, now finding the adjoint of this matrix, very simple, but you have to be very careful. Do you remember how you do it? Well, the very first thing you have to do is to apportion a sign on every one of these things from plus, minus, plus, minus, plus, minus, plus, minus, plus. So what I want you to keep doing now is to keep solving, and then let me be asking you what our, don't forget, in case you have forgotten, let me remind you that the adjoint of 3 by 3 matrix is given by what? Is the transpose of the cofactor. Just so you don't forget that. I'm sure because of many more knowledge you've had, some of you may be almost forgetting that, but don't forget the adjoint of a matrix, of a 3 by 3 matrix, is always the cofactor's transpose. So the first thing we have to find obviously will be the cofactor matrix. So how do we find the cofactor? So I want you to keep solving also, and let's validate our result together. So we have the first cofactor will be cofactor 1, 1 will be, of course, we have plus. So we're closing column 1, row 1, column 1, and we're putting in 1 minus 2, 2, 1. I will decide just to fill in for everything, then we can solve together. Our cofactor of 1, 2 will be having minus, this will be 2 minus 2, 3, 1. And then for cofactor of 1, 3, we'll be having plus, in this case, we are dealing with 2, 1, 3, 2. For those of you having issues in understanding what we're doing, you can go back to what we have done on matrix. All these videos are available already on how to find the cofactor matrix. So you can go back to check those things out so that you are able to understand it very, very much perfectly. This is, we are trying to just solve some past questions. This is last year's past question. So we're not doing so much of the explanation on these things. The cofactor of 2, 3, cofactor of 2, 3, oh, sorry, of 2, 1 will be minus row 1, column 1, we're left with minus 1, 1, 2, 1. And then the cofactor of 2, 2 will be plus, we're dealing with one, 1, 3, 1. Then for 2, 3, we're dealing with 1 minus 1, 3, 2. And we're dealing with a positive sign there. Sorry, a negative sign. In case you have forgotten, the use of all these signs are what you're seeing here. This is plus, minus, plus. We're using the signs we have attached to them right there. So for the next one, we have the last set, that's 3, 1. We have positive. In this case, we'll be dealing with minus 1, 1, 1 minus 2. And then for the C3, 2, we're dealing with, this is 3, 2. So we're dealing with 1, 1, 2 minus 2. And for C3, 3, we're dealing with 1, minus 1, 2, and 1. So can anybody confirm if I've made mistakes anywhere? In case you're following, I want to be sure I'm moving perfectly. So we can go on to try to resolve all these questions. I'm sure you are solving yours also. This is an opportunity for you to get grounded in these questions so that you don't make mistakes when you get into the exam hall. So we are trying to find a cofactor matrix now. So our cofactor matrix will be given as, so we want to start fixing our values for the cofactor matrix. All right, somebody confirmed that there are no mistakes. So for C11, our final answer will be 1 minus 4. 1 minus 4 will give me 5. So my answer here will be 5. Okay. And for the other one, we have 2 times 1. That will be 2 minus 6. 2 minus 6. 2 minus 6, that will give you what? 2 plus 6. That will be 8. That will be minus 8. I hope that's correct. And C13, we have 4 minus 3. 4 minus 3, that's 1. 4 minus 3, that's 1. So we have 1 because there's a positive sign there. Somebody said for C33, it is minus 2. Is it minus? I can't see what the person said again. Please confirm that. He said for C33, it's supposed to be 1 minus 1, 2 and 1. I think that's correct. Okay, for C21, we have minus 1, minus 2. Minus 1, minus 2. That will be what? Minus 3. Minus 3 times minus, that will be 3. So we have 3 right here. Please, can you all confirm those answers while you're solving yours? And for C22, we have 1 minus 3. That'll be minus 2. 1 times 1 times 3 times 1, that'll be 1 minus 3. That's minus 2. And for C23, we have 1 minus 3. That'll be 1 plus 3. Sorry, 2. 2 minus 3. That's 2 plus 3. That's 5. That's minus 5. So we have minus 5 there. For the last side of things, we have minus 1 times minus 2. That will be 2. 2 minus 1. That's 1. And for the other one, C32, we have minus 2 minus 2. Minus 2 minus 2, that will be what? Minus 4. Times minus, we have 4. And then for the last side there, we have 1 minus 2. That will be 3. So please, I hope you are all solving because, there is always a possibility for mistakes in questions like this. So can you all confirm that everything written here is correct? This is what we have as a cofactor matrix. Now, the cofactor matrix is given as this. So for us to find the adjoint, all we need to do is to transpose. Don't forget, we said the adjoint of A is the transpose somebody is saying that for C33 is 1 minus 1, and the person is saying we have minus 2. C33 cannot be that, because you are blocking row 3 and column 3. So what you'll be left with is minus 1, then 2 and 1. This, you have to cross-check that more properly. Can anybody confirm if what he's saying is the case? So looking at what we have here, we have been able to find, and this is a whole 3 marks. We've been able to find the cofactor. All we need to do is to transpose this, and the transpose will obviously be interchanging the rows with column. So my row 1 becomes column 1. So I have 5 minus 8, 1. I have 3 minus 2, minus 5. I have 1, 4, and 3. And you got your 3 marks. And you got your 3 marks. This is full 3 marks from last year's question. So once you're able to solve this, you get your 3 marks. The next question then went on to say we should find the inverse of matrix A. So this is what you're going to do for me in just 1 minute. Just 1 minute. Everybody find the determinant of matrix A, because I'm sure we all remember that the question number 2 said the inverse of matrix A using the adjoint. Of course, they don't want you to use any other method than they wanted you to use the method of A inverse being equals to adjoint of A over determinant of A. So if you know the adjoint to be this already, then they want you to go on with determinant of A. So if you fix this over determinant of A, you'll be getting your inverse. So can you, in 1 minute's time, give me determinant of matrix A? Everybody, without wasting time. We don't have to do that. Or do we have to do that? I think you guys are all familiar with finding determinant of a matrix. So I don't think we would have to solve that again, except if by popular demand you want me to still solve that. Do you want me to solve that? If you want me to solve that, please indicate that I can cover everyone. I'm not being biased to anyone. We can all solve it. Should I solve it? Are you okay? Oh, somebody said let's do it. Somebody said let's do it. Oh, we should do it. No, I can't just judge by one person. Somebody say yes. Okay, if somebody say yes, then I have to do it, because I want the whole class to be covered in this particular video. I don't want anybody to be isolated. So we have 2 different methods to solve the determinant. I can see people getting the same answer, and that's very, very nice to see. We're all getting 14. So that looks like the answer if everyone is arriving at the same thing. So if 14 is the answer, then obviously let's try and arrive at that 14. So for those of you that say you want me to do it, I'm going to use the second method, the faster one. I take it as the faster one. I have 1 minus 1. I have 1. I have 2. I have 1. I have minus 2. I have 3. I have 2. And I have 1. So what I'm going to do in order for me to get the determinant of this particular matrix is that I'm going to duplicate, using the second method, I'm going to duplicate this. So I'm going to duplicate column 1 and column 2. This is matrix A, obviously. Matrix A is what you have here. But I've duplicated column 1 and column 2 already. So what you have to do next is to, using the second method, is to going on to, you cross out the diagonals that are present. Cross out the diagonals that are present. That's simple. So, and then you go on to do your arithmetic where you subtract the minor diagonal from the leading diagonal. So let's try and do that quickly. Let's look at the leading diagonal. 3 times 1, this is 3, plus 2 times minus 2, this is minus 4. You multiply everything together, 1 times 2 times minus 1, this is plus minus 2, minus, we have 1 times 1 times 1, that'll be 1, plus minus 1 times minus 2 times 3, this will be 6. Because minus 1 times minus 2 is 2, times 3, that's 6. 2 times 2 times 1, that will be 4. So if I go on to subtract, of course, this is this minus this. So 3 minus 4, that's minus 1 minus 2. Minus 1 minus 2 is what? Minus 1 minus 2 is what? Minus 3. Minus 3, and this is what? Minus 3 minus, what do we have here? Are you sure we're on the right track here? Did you say you got 14? Oh, sorry. It is this minus this. Very sorry about that. Because, sorry, what I did was, this is the minor diagonal, this is the leading diagonal. So it is this one minus this, not this minus this. It is leading diagonal, this is the leading diagonal. This one we did here. What we did here is the leading diagonal. This is the leading diagonal. So it is leading diagonal minus the minor diagonal, not the other way around. So what we're going to be having is 6 plus 4 plus 1, that will be 11 minus what we had here, that will be minus 3. So that will be 11 plus 3, that will be 14. So those that got 14 are obviously correct. Okay, so now the final thing to do here for you to be able to get your inverse is going on to dividing all, this was your adjoint, you divide all this by the determinant of 14. And everywhere you are, what you have to do next is to divide each of them. So that will be 5 over 14, that will be 3 over 14, that will be 1 over 14, that will be minus 8 over 14, that will be minus 2 over 14, that will be 4 over 14, that will be 1 over 14, that will be minus 5 over 14, that will be 3 over 14. So anyone that is breakable down, like for instance, this one can be 1 over 7, and this one also, all this can be broken down. You go on to break them down. So because I want us to end this class at this time, the last question I was given, because that was not the only question that was given, you were told to also you were told to use the inverse of matrix A to find the solution of the system of the given linear equation. In that case, what you were supposed to do was that, don't forget that A inverse times X equals to B. So our X is equals to A inverse times B. This matrix B here was the constant matrix. The constant matrix we had when we had the when we brought out the matrix that contains the constant values. That's matrix B. So what we have as our A inverse now, which is what we got here, multiplying this with matrix B will give us our values for X. So this is where we're going to continue from in our next class tomorrow. So I want every one of you to go on and write this down if you need to. I hope you have taken a good note down. The very first thing I'm going to be asking is your answers for this particular question. I want to know what the matrix X answers are. This is last year's question, so I expect you to take it quite very serious because it's a question that obviously is very likable to very likely to come out. So this is a 7 marks question. Tomorrow we're going to be solving questions on mathematical equations and logarithm maybe, and some other of all these questions. These classes are dedicated to solving lots of questions. There are several questions to solve, and we'll keep on solving them right in this particular class. So I hope to see you guys tomorrow. Charge up your phones, get yourself prepared, take good notes, get your calculator around, do whatever it takes, because this particular year, the target we have must be achieved. And I'm sure you guys can do it. It's really in you. You have the power to do this, to achieve this. So don't relent, burn the midnight oil, do whatever you need to do to achieve great success. All right, guys, I wish you guys a very happy night rest, and I really hope to see you tomorrow.